The databases is normal, meaning the database which we create for our day-to-day use, for institutional use, for our use, and the online database is an information product which give us a specific information on a subject through online. So both are conceptually almost same, but usability is different. Usability is different, right? Probably your contact list will search by you. I am not going to search it because it's your institutional data. If you are the part of the institution, you are going to search it. I am not. But when you talk about the online databases, the general database, or kind of specific subject-specific databases, it will for everybody. Everybody will search on that. So it's a public interface. So user interface is bigger. It's public interface. Now coming to that particular content, what we are going to use cover in this chapter: introduction, information retrieval versus data retrieval, parameters for evaluation of search output, search strategy, compound queries, advanced feature, keyword grouping, truncation, proximity operator, limiting search, trained in information retrieval. These are the components we are going to cover in this lecture. Now, information retrieval versus data retrieval. What exactly information is? What do you mean by information? Information is nothing. It's a combination of data. When data got filtered, then it becomes information. So information is a wide term. Data is a pieces of information. So before evaluating both of them on aspect of a retrieval feature or retrieval complexity, just think the basic meaning of both the concept, information and data. Information is complete. Data is piecemeal, fragmented, different, point to point, right? So when it's come as an information, it's a probably what exactly we call it. Just a minute. It's a kind of sentence sometimes. Group of data when we talk about the information retrieval. But information retrieval is very specific. Suppose I want to search today's humidity in the air. That is the data. When we talk about throughout the week, how the humidity will be in the air, that is the information. So data could be on a particular date, but when you think of when I'm searching data on a humidity in the air, that probably give you reflected as a information because it's take the total day's humidity altogether. But when I'm asking computer just to give me the data right now, what is the humidity of in the air? That is data. That's the basic difference between the information and data retrieval. So information retrieval, when you think of information retrieval, it's a combination. It's a combination of the concept, right? It's a total concept. It's not knowledge. It is the information, of course, but it is not data. So data is it's a pieces of information, right? One by one. So data will come together and can create one information. With the data of raining within Delhi that period, probably it will give you the total rainfall in Delhi. But probably you will see that many of the places you didn't got the showers. There is no rain. When you come into the data retrieval system, then you will understand, okay, this area has no rain, but total information is raining is that much millimeter. So that's the basic difference from the information versus data retrieval. Now, parameter for evaluation search output. The most important concept in the databases is recall and precision. Is that when you are searching one database, suppose you are searching through Google, is that all information came? Whatever the database of the Google probably kept all the information. So how many information, relevant information has retrieved? And the next is total, how many relevant information from total information retrieved. So both are different. Suppose there are many informations available in the data, and when you are searching, so it has came some result. Is that the all relevant information has came out? This is one question. Secondary question is, when you are searching a data, and data give you output, is that the in total output, is that the all information are relevant to us? That's the basic difference. Now, a measure of ability of IRS, information retrieval system, to retrieve relevant document, right? So the recall is nothing, it's a retrieving the relevant document available in the databases. When its precision is concerned, is a measure of the ability of information retrieval system to withhold irrelevant document for being retrieved, right? It should retrieve the relevant document itself, not the whole document. That's the basic concept between the recall and precision. Now, search strategy, how we are going to coin the strategy before going to search anything. Understand the user requirement. How user? There are many times in the morning, I have already shown that when I am searching, suppose I am searching NFC enabled library application. So I am searching, but our requirement is we're not going to see how many websites are giving that information. Our option, our strategy, our concern was how many article, full text article available in the free and open sources on NFC applications in library information system, right? So that's why I have given PDF. So it is give us only the PDF file, not the website. So that's our requirement. That's why I have search right that way. So searching itself is today's date is a subject. One has to know, one has to keep up their ability in searching. Probably I often says there should be a training program on how we are going to search it. Selecting, now I will tell you one important aspect is, suppose you are searching in Google, NFC enabled library. You see, let me reduce some of the, this is came. This is in a normal search option. If I search NFC enabled library system PDF, it will search different. Now, the same thing I am searching in Google Scholar. No, take this one. Just copy it, go Scholar, Google Scholar, go to that and just try to find out. But it has given all the PDF document and from a peer-reviewed journal. So that's the important part, where you are going to search for what kind. So you need to create a search strategy and what is a requirement of a particular user. If you go to the ResearchGate, go to the ResearchGate. Go to the ResearchGate.net. You have to log in on that. Okay, here you can search. I don't know. Yes, it has given some ideas. Yes, you will see there are journals. And there are many journals. So these are all peer-reviewed journals. So that's the basic difference. this is a general database for the all people. But when you come to the Google Scholar, it is for the academic people or the people uh, who are in research. A Google ResearchGate is research, but here everybody will search. That's the basic difference. Now coming to the Emerald, people probably if you ask many people in your society, very people, one or two, can able to understand the concept of Emerald. So here, if you search paste NFC enabled library system, I do not know, you have to log in on that. Or yes, it has come in. So these are the article, and why I am searching over here, Google Scholar, ResearchGate, Emerald, because I want authentic information. In Google search, the information is coming there. There may be no authenticity. Who has created these journals? This article may not be authoritative. Here it is peer reviewed, authoritative. You can find the person name who had published that one. So that's the basic difference in the general search and the specific database search. Coming to our concept. So selecting the database to search is important task, not searching in JSTOR. Because JSTOR is Elsevier science. Because these may not contain our information. Their subject coverage is different. If you see their subject by subject, you will see it's a different subject. The subjects are like that. What are the area? African American studies, architecture, business, economics. There is hardly we find information on the NFC enabled library applications over here. These are the subjects they have covered. But yes, social science, they have covered library, information science. So let's start search. Again, but no. They have not used extensively. That's why they're not able to give us the exact information. That's the basic difference from one database to other database. So we need to understand what is the database and their subject coverage. The accessibility, period coverage is important. Suppose the information you are taking, information you are taking for your research in this time. So you need to take the article up to 5 years back, not 10 years, 20 years back, because those articles could not fulfill our requirement, our demand. So we need to understand what is period coverage, is that the database are covering the recent article or the old article. We required in a research, we always required a recent article. So period, then search field. Is that particular databases allow you to search in a different criteria? Then search device tools. Is that the databases is feasible for the voice search or the assistive technology? Assistive technology means a blind people can able to search the databases. That is important aspect. Then the performance, etc. What is the performance? Means how frequently they are able to give you the feedback. If you look at the search capacity of Google, you will find 0.39 second. Here you can see 39 second, about 8,50,000 results in a 0.39. You can understand the capacity of the Google's databases. But here you will 0.35 second. It takes less time because you have specified PDF. Here 0.6 because the database over here is lesser. That's why in Google Scholar it has given only 18,000 because here you are getting 8,50,000 data. Here in Google Scholar, you are getting 18,000. Why so difference? Because it has given you the whole data without any evaluation, without any restriction. But here in Google Scholar, it has restricted to the peer reviewed. So that's the basic difference between the database. Here, if you see the data, I do not know they have mentioned the time or not. It has not mentioned. It has given you the, so search performance in a database, some of the databases are doing that one. They're giving you the exact search time and result also. So here you have seen that all irrelevant, irrelevant. There is no relevant concept we have received in JSTOR. Same thing could be done in the LGBA science. So why we are taking all those information? Because we have restricted to a particular database. The performance. Then formulating search statement. Formulating search statement is nothing. When you are searching, in your search, here you can see your search. Have a three component. One, NFC, near field communication. Second is enabled. Third is library. So you have a three terminology. So what I have done over here, I have made it four terminology, more specific, right? So when you are searching any component or anything, you need to create a search statement or search formulation. Then only your search will be accurate search. Otherwise, it will be difficult. Coming to the compound search, it's basically Boolean search. Papi Kitchen, it's and or not. We'll see how we are going to use it. Come over here in the Google or come to the, I don't know, here it is there. In advanced search, if you click advanced search, in they have not, they do not have. They do not have. So we'll come to the Google search setting. If you go search setting, if you go advanced search, you will find definitely Boolean concept. Is there Boolean concept is there? Any words, exact word, number of ranking form, none of this. So yes, any of these words, type or between words you want to miniature or standard. Here, NFC or RFID, NFC or RFID. So that kind of concept, that kind of strategy you can build up. So Boolean search is a very old concept. It has started in the year 1970s, before 1970s. Still it is going on. And it is a very effective component in search strategy. I want NFC or RFID library system, you will get both the concept. NFC or RFID. So you will take everything. Now you will take NFC and RFID. Again, you are going to able to retrieve everything. But when you constrain with the concept of not NFC, not RFID, enabled library service. So the search result will come with the NFC itself. That's the basic usability of your compound queries or the Boolean logic. Now, there are many databases in this world right now. Throughout the world, the keyword grouping is a very common. Then truncation, proximity operator, limiting search. So truncation is nothing. It's a, suppose NFC. In C, you can truncate it with the wildcard. So that will give you, keyword is completely a keyword kind of thing. NFC, only you are putting NFC library, two different, not enabled. In keyword grouping, truncation, you can truncate it with the wildcard. Proximity, how suppose in the common words is Projesh, Projesh, Projesh. So in this, when you are indexing this particular page into the computer, it will map the proximity of the search. When they will find the same terminology appearing many times within that text, it's become a proximity of proximity operators. These are the proximity. Then relational, then it is called limiting search. Yes. Suppose I want a journal coming to over here in advanced search. Here is a range limiting the search. When I am searching in FC in a build library, here you are just 2010 to 2020. You are limiting the search, limiting the database. Now search it. It will give you the result within 2010 to 2000. Now see, it has started from 2015. I do not, 14 also is there, but you do not find anything in 2009. So everything will come from 2010 to 2020. This is a concept of limiting the search. So that's the strategy.
Sir?
Right. Sir? Yes.
सर प्रॉक्सिमिटी का जैसा आपने बताया, थोड़ा सा एग्जांपल सर गूगल पे मिल जाएगा?
ये बहुत है, अभी आता हूँ प्रॉक्सिमिटी में भी, ट्रांकेशंस में भी आता है. ठीक है. ट्रेन बड़ा इजी कॉन्सेप्ट. Now recent trend in information retrieval. In information retrieval is a new concept. It was old previously because it was restricted to the chosen few people who are on academic. But right now, everybody is searching from the computer because our life is restricted to our mobile phone and PC or laptop. So every time we're trying to search many information from many different databases, and majority are online databases. And in online databases today's date, searching itself is a difficult task, because what I am searching, sometimes you will find that you are not able to get it, and when you are not searching, the information is coming up automatically. That's the dilemma of searching. Second option is there is no such training program for searching online databases. Majority of us learn heuristic approach, because heat and trial. We have learned from a heat and trial. That's basically called heuristic approach. So we need to understand the trends in information retrieval throughout the world, especially in India. We have gone through many universities and we have collected data. And why we required to understand the information retrieval, because if you look at the trend of global publishing market from 2018 to 2020, it's a huge growth in the electronic journal, e-resources, right? This is 61%. Now coming over here, if you look at the CAGR report, up to 2023, in Europe itself is a huge market of e-book. So e-book is growing rapidly. Coming to in January to June 2009, so trade revenue by format, you will see here the e-book format. It is almost 22.3% of your total market area, right? This is paperback mass market, physical audio, board books, and other. It's a handbook, the printed book. This is a digital format. Coming to the e-publishing e-book global sales from 2015 to 2019, $29 billion, 16% growth. The overall growth, if you find, it is 93% from 2015 to 2020, within a 5 years of time. Look at the strategy, the usability of ebooks, how it suppressed the e-print. United States, if you look at here in 2018, an ebook, 2018 printed book and ebook has claimed higher. In Japan, it is growing. Germany, it is growing. China, it is growing. Italy, it is growing. But Britain is cover up. They're reflecting higher. The most advanced country in this world, both US and Britain, where people are reading. Here you can see the different scenario because ebook is growing. Coming to the projected data storage throughout the world from 2012 to 2020, it's here 40,000 exabytes. Could you imagine the quantum of data requirement? Because every day something is going up. Even what I'm teaching you, that will also go to the YouTube. So the growth, you required to keep all those content in a one place. When you are printing a book, it should be go to a library or a person's house. So you have ample space. But here you required one place. Suppose I am putting something on YouTube, it is or Google or Drive or something somewhere else or Vimeo or any slide. There is a one slide. What is called it? Slide player where slideshow is going on. So these all are places where we are going to put. So where up to 2020, it's growing fast. So we need to understand the values of information retrieval. If you look at the information retrieval history in 1970s, Boolean vector space model. In 1980s, LexisNexis and Dialog Modeler came with the concept of OPAC. In 1990s, Archie's Voice. This is the internet surface. Then it came Lycos, Yahoo, Alta Vista. We have used extensively. Previously, there was no Google. We used to search everything in Yahoo or Alta Vista or Lycos. Now in 1990s continued, NIST, Trek, Ringo, Amazon, Net Perception has came into forefront. Trek has taken into different way. They research, they evaluate, and they recommend many things. Now in 2000, Google came with like a giant, and it has created one of the finest databases, which is readily available for everything. Today's date, there is hardly requirement of any encyclopedia. Google itself is an encyclopedia. Then Trek question answer track is also there. Then in 2000, it has immediately came image video. Previously, we used to search that character only. Now, image, video, audio, music, everything came up. Cross-language, DARPA tides up. Document summarization, learning to rank. This came in 2000. Today's date, when I'm talking to you, we are using either in this computer, I have seen what it is called, Corantas. I'm just speaking them, it will automatically search the things. Google Talk, Google Mini, Alexa, IBM Watson. It's a voice recognitions, information retrieval. You tell them, they will search for you. That's the technology has developed in information retrieval. It has grown like extensively. Coming now, I have already talked about that. When you are searching something in YouTube, they're giving the same repeated other videos for you. How it is possible? Because they are using artificial intelligence on that. They map your search strategy. They map your mind, what you are watching. So immediately they trying to show you other avenues of your knowledge. So you can explore that. They recommend you. This is only possible when you have a artificial intelligence, machine learning, deep learning concepts. They can map the ideas of human behavior. So this has come up with the information retrieval. That's the added value addition in the information retrieval. Then what about the information artificial intelligence researchers who were trying to do intellectual analysis automatically? The problem of over-promising result for the machine translation and computational linguistic affected them as well. But in 1970s, speech recognitions are becoming an expert system. Nowadays, you probably will find you are also searching through different language. That is only possible when you have a multilingual facilities also. Here, the problem of RF information retrieval is you are thinking different one thing, you are searching for that, it is going to the document collection, it is giving you the list. Sometimes it is not giving you what you are asking for, you are searching for. It is irrelevant, not always the relevant information. Still there is a problem. Because there are two concepts over here. One is that all human mind is ready to search? Is that they are capable, they have been trained for searching? Second option is that your system, information retrieval system, is efficient enough to search everything which you are searching for. But it has not. Sometimes it appears like that. Now, if you're searching something in the Google, sometimes it's give different information. That's the problem. How the information, even they are not bothered about the classification of knowledge. They are not putting everything one by one in a knowledge management way. This is document indexing, representation of the keyword, query evaluation, and return back keyword representations, query analysis. These are complex process, but it is based on the proper indexing and representation of the keyword in information retrieval. The main complexity in the information retrieval today's date, document and query indexing, how to best represent their content, query evaluation or retrieval process. To what extent does a document correspond to a query? System evaluation. How good is a system? Are the retrieved document relevant? Are all the relevant document retrieved? This is both vice versa. It's an important question in information retrieval. What we are doing, what is our role? If you look at the role of a library, probably you can see here, we have a philosophy, we have experience, we have the skills, we have evaluations, we have a user, we know the user need. Suppose a library like Library of Congress, which book shelf is almost 526 miles long. If you till date, if you ask for any book, they will go and you can able to find out the one specific book in a one remote located locker, a rack. Why it is possible? Because you have a philosophy. The problem of the information retrieval system is that the best brain in this art, they are more into the computer. Sometimes they forget the common man usability. So that's why the problem is. If you look at the Shodh Ganga in India, can you imagine department center thesis views 4 crore, 48 crore, 90, something like that, 4 crore 98, 89 lakh, 13,034 thesis viewed. University views right that 50 lakh 75,892 search performed. Can you imagine the quantum of search being done every day? Page views 43 crore 94 lakhs 25,467 page. So every majority people in India are searching. Here you can see the month-wise usage of e-journals and e-book 2017-18 in the N list. Quantum of journal and ebook being searched in our databases through internet. So people are searching in India. They are more proactive. Here, month-wise page view from subscribe e-resources under N list. This is, they have, you can see the quantum of page viewed in N list up to March 2018. So we are searching, but importantly, what we are searching, it is not always available in the database, or it could be available in the database, but I am not able to search it. So what its effect? The poor performance of the student in various universities, it has been studied that because of they are not able to retrieve proper information, so that's why they are not able to come up very good in academic work. In many universities, still it is happening, majority of the country, not only in India. If you look at the Indian scenario, the majority of the information retrieval being learned from self-instruction, 31% from the friends and colleagues, 17% from the library staff, 27% heuristic approach, trial and error. Your browsing feature is almost common in online databases in Indian universities. This is browsing feature. Then the feasibility of site. Here you can see JSTOR has highest average. JSTOR has a better information retrieval system. Taylor and information, Taylor and Francis need to be improved. Through this research, it has came. Here you can see accessibility feature is almost the same. These are the basic information retrieval need to be enlisted in the each and every online databases available throughout the world. There should be a very simple entering a search, navigation within search result, displaying an article from the result list, searching for a particular journal issue, link to a related internet link, finding the relevant rating for each article, means the article which I am finding, what is the rate of that article, using go to the base part feature of an article, displaying the definition of a word in an article. That's need to be incorporated. Secondly, advanced data retrieval need to be incorporated, Boolean logic, field specific search, have a rules of precedence with nested queries, limited search field, which is lacking many online databases, match exact word and phrase searching, proximity search, range search, saved search is not available in many online databases. Search history, stemming, subject search, truncation, use of thesaurus and permuted index for searching, wildcard. It is not available in many online databases. In unique database retrieval technique like article locator, article type, automatic translation software, citation search, classification code, cross-reference search, custom link, density of term, explode, expand search, emailing an article from the result list, emailing citation from the result list, frequency of term, fuzzy searching, Google custom search, help menu on online tutorial, hyphen search, journal browsing, lateral search. Obviously, lateral search cannot be applied to every online databases. It should be restricted to the social science or humanities. Specifically, this is made for the humanities. Mapping, nested queries, persistent link, punctuation mark, query by example, reference link, search for common phrases, smart link, sort order, special character, spell check, stop word, subject authority, suggest, subject heading, table of content, time cited, that need to be incorporated in majority of the online databases. In India, We're not going to evaluate any online databases, but at the same time, we need to understand the performance of search in the online databases. If you look at the American Chemical Society, American Institute of Physics, American Physical Society, Annual Review, Blackwell Publishing, Cambridge University Press, Emerald, Elsevier, Institute of Physics, JSTOR, Oxford University Press, Project Moose, Royal Society of Chemistry, Taylor and Francis, and WI, probably there is an online databases. But out of those, you will see the Elsevier has a better unique features. Project Moose has a unique feature. Emerald has a unique feature. American Physical Society has a unique feature as there. But basic feature is almost common to all. Advanced feature is still sometimes common to all. But somewhere is American Chemical Society is better. Emerald is better. Elsevier is better. JSTOR is better. Project Moose is better. But in case of unique, you will see some of are lagging behind. They need to be take care of their online interfaces. So that's why people are not able to find out the exact information which they require through information retrieval. If you look at the Indian scenario of searching, this black area, black portion, is covered by everybody in India, but still there are some portion in the databases, this white area. It's not still covered. The day it will be covered, then it will be a new sunshine for everybody. Thank you so much.